Hello students, we are starting today with the principal quantum number as we have introduced. Quantum number is the previous class, okay? Principal quantum number. I have told you that there are four types of quantum numbers. Principal quantum number, azimuthal quantum numbers, magnetic quantum number and spin quantum number. So we are discussing only two today. Tomorrow we will discuss the whole of azimuthal and then spin, okay? So today we will discuss two quantum numbers, that is principal quantum number. Represents the orbit number, okay, and is represented by small n, okay. It's represented by small n. But n is nothing but it is a positive integral factor. N is a positive integral factor. Okay, n is represented in the form of what? Positive integral factor. Integral factors. Okay, that is 1, 2, 3, 4, 5, and so on. Matlab represents the orbit number. You know very well orbit number is what? The energy levels we are talking about. Okay, that is represented in the form of what? Orbit number, and n is representation of it. Okay. Now that means what? If you take it like this one, is the nucleus. This is the first orbit. Okay, that is n is equal to 1, then n is equal to 2, then n is equal to 3, and so on. Okay, the n is the positive integral factor, that is 1, 2, 3, 4, 5, like that way. Okay, the number of electrons present in each orbit is represented by 2n square rule. 2n square rule, where n is the number of orbit. Okay, so if I take it like this way, 2 into 1 square, that is equal to 2. Why 2 into 1 square? Because 1 is there. First orbit, that means number of electrons is always represented in the form of what? 2n square rule. 2 into 1 square, that is 2. 2 into 2 square, that is equal to 8. 2 into 3 square, that is equal to 18. 2 into 4 square, that is equal to 32, and so on. The representation of each and every particular orbit having the number of electrons present will be represented in the form of what? 2n square rule. 2n square rule, and that is 2, 8, 18, 32, and so on. Is it okay or not okay? This is how we represent the whole of principal quantum number to be discussed. Okay, principal quantum number is represented by small n and it represents the orbit number. And orbit number is designated in the case of what? Positive integral fact, that is represented in the form of what? 1, 2, 3, 4, 5, and so on. Okay, and this is how we go for it. Now see students, the problem arises is the principal quantum number when we speak about the principal quantum number in detail. Okay, so what will happen? This is the principal quantum number to be discussed. Now see, the whole thing can be represented in the form of azimuthal quantum number. See this one, azimuthal quantum number. You see, the next one is an azimuthal quantum number. Azimuthal quantum number. Azimuthal quantum number is what? See, principal quantum number is what you have understood. That is representing the orbit number. That is represented in the form of what? 2n square rule. Okay, the number of electrons present in each orbit is represented in the form of what? 2n square rule. Okay, and in this case what happens? N is the number of orbit over here. Okay, now azimuthal quantum number is what? See this, when you see a nucleus over here, when you see a nucleus over here, and this is what? The orbit. Undoubtedly you know that this is an orbit. Okay, undoubtedly you know that it's an orbit, but you are not sure. Orbit is not a perfect pathway, it's an imaginary pathway. It's depending upon the energy level. See, for example, if an electron moves in 3 joules, the electron is present over here. Chalo. 3 joules, the electron is present over here. And if an electron, other electron moves in 3.2 joules, that means neither it is in the third or this orbit, that means it will create new more orbit or not. Please listen to me. Say for example, this energy is what? Level is 2 joules. The electron is migrated with 2 joules. But if the electron is having 2.1 joules, will it move over here? Will the electron move over here? No. It will be moving a bit away from the first orbit or not, tell me. That means it will be moving over here. Correct? ठीक से समझो. This is the first time you are studying like this way. This is, say, the electron is moving with 2 joules. This electron is moving with 3 joules. If it is moving with 3.2 joules, that means what? Electron is moving in 3.2 joules over here. That means electron will not move over here. The electron will not move in this particular orbit, but will move a bit away from this particular orbit. If it is moving with 3.8 joules, like this, that means the factor is what? This is the first orbit, the second orbit, and this is the third orbit. That means the electron was moving with 3 joules in the third orbit. 3.2 joules is kya? More towards the third orbit. Okay, more towards the, second orbit. The electron was moving in the second orbit. Then 3.2 joules, that means it is moving more towards the second orbit. And 3.8 joules is moving more towards the third orbit, or not, tell me. But it is not towards the, exactly on the basis of what? For second and the third orbit over here. It is moving away from the second orbit, third orbit. That means it is creating a new type of orbit, or not, tell me. This new type of orbit is called suborbit. Okay, suborbit or sub-energy level. Correct or not, tell me? The sub-energy level or suborbit. So, again I repeat the whole thing. This is a very important concept. If the electron is moving in this manner, okay, and if the electron is moving over here, okay, the energy is what? Such that it cannot move in this orbit, moving a bit over here. That means it's moving away from the first orbit. Okay, and if it is moving this way, that means it is moving away from the first orbit and towards the second orbit. And if it is over here, that means it is midway between the first orbit and second orbit, or not. That proves the fact that the orbit is further subdivided into what? Suborbit. Orbit is further subdivided into suborbit. Okay, so azimuthal quantum number only represents the suborbit number. Azimuthal quantum number represents the suborbit number. Okay, represented in the form of what? L. It is represented in the form of L. Remember, this is a very, very important concept. You have never studied that orbit number is there, and orbit number is obviously being converted into a suborbit number. What is it? Again I repeat. If you don't understand this one, we will not be able to proceed at all. Again I repeat the whole thing. This is 3 joules. Okay. If the electron is moving in 3 joules, the next electron moves around in say 3.2 joules. Okay, and this is what? 5 joules energy here. Okay, the next electron moves into 3.2 joules. That means it is moving away from the first orbit. Okay, that means it is much more moving away from the first orbit. That means this is the movement. And if it is moving like this way, that means what? 3.4 joules. That is, say, 3.8 joules. That means what? The electron is now not placed in the first orbit, but is moving away from the first orbit. It is towards the first orbit, or towards the second orbit, or away from the first orbit. Okay, that means what? It is this is the orbit is further subdivided into what? Suborbit. That swing through. And suborbit is represented in the form of what? L. And if I take it L, L will be considered to be a n minus 1. Okay, L is always considered to be a n minus 1. Okay, and this is what the representation of suborbit is there. So tomorrow we will be discussing about this azimuthal quantum number in detail. But this is a very important thing, that the orbit can be further subdivided into what? Suborbit. Okay.